Good afternoon, everybody, and welcome to DigiCore's LinkedIn Live series. And we are talking to digital twin experts, people in the digital twin world, influencers in digital twinning, all about digital twinning, basically, because DigiCore is, of course, part of the whole digital twinning movement that's happening at the moment. And we're delighted to have our CEO, Naeem, here with us. And we have a special guest, Rob Tiffany. And if you don't know who Rob Tiffany is, oh my gosh, he's one of the biggest influencers in the digital twinning space. So we are honored to have you here with us today, Rob.
Thanks for having me. It's good to be here.
Welcome. And Naeem, you're based in London. Where are you, Rob?
I'm in the Seattle area.
Do you know, it's funny, this week someone mentioned Seattle to me and I said, I know someone in Seattle. So I must remember what that was.
Yeah, I'm right close to Redmond, Washington, which people probably don't know what that is, but it's the headquarters of Microsoft where I spent most of my career. So that's why I'm here.
Ah, okay. Well, Rob, tell everyone a little bit about yourself.
Sure. Yeah. So I'm a research director at IDC. So, an industry analyst firm, kind of like Gartner and Forrester and all those guys. And so in that role, I'm focused on kind of multi-cloud, hybrid, private cloud, scenarios, edge, that kind of thing. Background, I used to drive submarines a lifetime ago when I was in the Navy. And so, which is actually how I got to the Northwest, believe it or not. Spent most of my career at Microsoft. Does anybody remember Windows Phone? With the tiles. Okay, so my first half at Microsoft was Windows Phone, Windows Mobile, and then the second half was designing and building Azure, the Azure cloud, and then specifically Azure IoT. And so, got to be one of the co-architects of designing that system, and it was cool building something that big around the world when building this giant cloud. And kind of digital twin stuff grew out of a lot of that work. But I got recruited out of there by Hitachi. And so I went over to Hitachi to help them create from scratch an industrial IoT platform, which was a great experience. It was called Lumada. And that's probably where I got into digital twins. That was like 2016 timeframe. And so I believe, I just started seeing a few things from like Dr. Michael Greaves, who kind of might be the father of digital twins or whatever. And it became apparent to me that digital twins probably should be at the heart of an industrial IoT platform, because that's the way we want to model that real world. Before that, people weren't modeling anything with IoT. It was just, I got a device and some sensors and magic happens. And so that was a great experience getting to build and design something like that from scratch. So I was the CTO there, and then I took a role as a VP and a GM of IoT at Ericsson. And so instead of being in Japanese factories, I gave that up and started going to Sweden. And so I was in Stockholm all the time. And the IoT stuff there was a little different. It was more around connectivity, connection management for devices. And of course, there's that constant drumbeat of 5G in the background the whole time for the handful of companies that make 5G. And so yeah, cool experiences for sure.
Wow.
Wild ride.
And Rob skipped all his veterinary stuff. He's a great veteran, isn't he? And apparently you're great at making cookies as well. Is that right?
Maybe.
Apparently so. Apparently you're known for your cooking tips.
Well, Naeem, tell everyone a little bit about yourself for people who don't know you.
Rob, and hi everybody listening. Naeem Atta. I'm CEO of DigiCorp, and DigiCorp is a company I founded back in 2015. And my early career is I've probably been in IT for about 30 odd years, and it's all been software engineering, software development. And the only I suppose I've got some overlap with Rob's background in the sense that I did simulation models for submarines, so I'd never got in there. I never managed to drive one, as Rob said, and I also did for the Royal Air Force. I did simulations for at the time Harrier aircraft, which were in operation at the time. And so my background is simulations, and as you know, Rob, simulations are kind of closely knitted to digital twins. They're sort of the foundations of what digital twinning started, and as the thing simulations got more and more complex, got quite close to the real thing, the physical entity with their counterparts. The term digital twins was coined, and Digicorp we specialize in sustainability and digital twinning. So those are our core two skills, I suppose.
I love it.
But thank you.
We should just talk about digital twins of submarines the whole time.
Well, I know nothing about. I was in a submarine. I went to visit one in Cherbourg, and it's pretty cool. So yeah, we'll definitely maybe we could do a whole episode all around submarine. Sure.
Not for everyone, if you're claustrophobic.
Not for everyone, no. So for anyone who is watching, folks, thank you so much for joining us. We have 58 people watching already. So thank you so much, everybody, if you've just joined us. If you have a question, please put it in the comment section and we will probably feature it, and we'll ask Naeem and Rob, because we have two digital experts here on screen right now. So I suppose the first question I would like to ask for people who maybe are like me, that aren't very familiar with digital twins. I'm getting better though. What is a digital twin, Rob?
Oh no. Well, the easy answer that you often hear is it's like a digital representation of a physical object or maybe a system, things like that. It's always better to try to, I don't want to say dumb it down, but try to make it understandable. And so a lot of times when I try to describe it to someone, I was like, well, imagine you had a car, or a pickup truck. And so you've got the physical twin, the real thing, what people missed out on a lot in the Internet of Things. What's the thing? Oh, the thing is the physical twin. And then you've got the digital representation of that thing over here, right? And so the physical thing's got all these properties, attributes about it. So your car's got 4 tires on it, and what are you measuring in the tires? Well, maybe PSI, pounds per square inch, but it's probably something different where you live because you don't do pounds anymore. But in the US, we live in the past, right? And so you've got an engine, you've got transmission. So you've got all these different elements of things that are working on a vehicle, right? And you create digital properties, and attributes. And so if I might go, yeah, this digital twin of a truck has 4 tires. And what do I care about with the tires, for instance? We'll just zoom in on that property. I care about the PSI. Is my tire inflated properly for driving? And maybe the green zone is 33 or 32 PSI is a good inflated tire. And so when you have properties of this twin, you might say, well, what am I measuring? Because remember, we're all measuring a lot of these things. That's what IoT is. It's measuring something, right? Remotely knowing something. And so I might go, well, this is so nerdy. Okay, what kind of data type is it? Oh, it's an integer or it's a floating point thing. But maybe I just don't care. It's a whole number like an integer, and I want it to be in this range. And so without doing anything crazy like machine learning or stuff like that, if you're just doing basics like KPIs, thresholds, stuff like that, you might say the green zone is between 31 and 35. And then the yellow zone is it's getting a little flat and it's a warning area, or it's getting too overinflated, and a red zone. And you might take actions on that. That's kind of a simplified way. And of course, like any space, any world that you talk about with technology, people love to make things really complicated because it makes them look smarter, right? And you have to do that, And so
you make money from it, right?
That's right. And so you start off with this thing called a digital twin model, or sometimes it's called a digital twin prototype. And what I mean by that, it's a type of a thing, for instance. And so I might have an asset class of a Ford F-150 pickup truck from 2018 is the model, and it's got all its attributes. And then there's a digital twin instance, the actual Ford F-150 pickup truck on the road. And there may be 1 million of those. And again, if I overlap with twins and IoT a lot, it's because digital twins need that telemetry pipeline, that two-way connection for data, the plumbing, right? Because it's not just a digital model, it's alive. As the physical twin is changing, it's going faster, all kind of temperatures are going up. Whenever you look on the dashboard of your car and you see all this information now, imagine that just remotely going somewhere else. to your digital twin. And so you're keeping it alive. And so someone could look at a whole fleet of these pickup trucks and see what's going on. And then you can apply analytics to that information. So there's models of it, a type of thing, and then you inherit from that type to instances of the actual thing. And then, there's the properties, there's static information, properties of that thing, which don't change. Like it might be this truck is, 22 feet long and the fuel tank holds this many gallons or whatever. And those are things that don't change. Or this giant wind turbine on a wind farm that I'm generating electricity. There'll be static information, and then there's dynamic information that changes all the time. I'm just kind of rambling here.
All that.
Someone, Matthew has mentioned he's having trouble hearing you, so maybe we make sure we have microphone next time. I don't know if you have one there handy or a headset with a microphone.
I do.
Right next to me, maybe.
I have a microphone.
Is that better? I don't know.
Yeah. Well, just I know, Naeem, you have another example, which is the Apollo 13.
Yeah, Rob's. I've heard Rob talk about this as well. Rob back in that was a long time ago, right? Back in 1970. So Apollo 13. I'm sure if some people maybe here a bit young for Apollo 13, but they've probably seen the movie, right? So what happened? There was an explosion in an oxygen tank, I think it was, and the center of gravity changed for the aircraft, and they lost fuel and damaged some of the thrusters, and they lost some oxygen. So what did they do? They had all the data being fed back to their simulators, because they had very complicated sims at the time. And they just modeled the sims to be exactly like the damaged aircraft. And they said, right, how many maneuvers, how do we use the thrusters? How do we maximize our efficiency so the craft lands back to Earth safely? And they practiced on the digital twin until they got it right. Is that right, Rob? And then they went back and no, more or less. Okay, so
well, they weren't as advanced yet, right? And so if you watch the movie, which I always thought was funny, you've got Tom Hanks up there and Gary Sinise is in Houston, Forrest Gump and Lieutenant Dan is basically got back together again to rescue the spacecraft, right? But it was a great example because, and it's talked about how far we've come. So back then they built a physical twin of the spacecraft. It was at NASA in Houston. Mm-hmm. And so you watch the movie and Gary Sinise, and they're trying to solve these problems, right? What came out of that was some thinking that says, wow, wouldn't it be easier if we had a high fidelity digital version of this spacecraft that we could troubleshoot all these problems? Because we won't always be so lucky to have a complete replica of a real physical spacecraft. Not everybody can always do that. But it's such a great example to illuminate why a digital twin is important. Because obviously if you watch the movie, you'll see all the problems they solved, which actually I heard was the inspiration for the book and then the movie, The Martian. If you ever saw that, which was solving one problem after another on Mars when you think you're not going to make it, what's his name? Andy Weir, who wrote The Martian, was inspired by Apollo 13 because it was like, solve this problem, then solve the next one, then solve the next one, and maybe you get to come home.
So really like with digital twins, like the evolution of digital twins. So how have digital twins evolved over the years, and what key technological advancements have driven their adoption across industries? Rob?
Before I was going to say, Rob, before you answer that, just one thing, Sam, is worth mentioning is that why all the hype now with digital twins? And that's kind of leans into a bit of the question you're asking. That is, we've got, the sensors have become so sophisticated now. Your phone has so many sensors and cheap and very accurate. Yeah. So that's one aspect. So that collects the physical environment. And then you've got much better networks. You've got 5G now in areas where you didn't have. And dare I say 6G is coming around the corner. So
oh, God.
I shouldn't have said that. Is that a swear word, Rob? I don't know.
It's like a drinking game, I think. I don't know.
There's that. And then there's, the analytics platforms have got quite advanced, which Rob has obviously helped work on some of the Azure cloud things, and then on top of that, you've got this liberal sprinkling of AI, right? Which we need to sprinkle everywhere, it seems to be these days. So all those things, and then you've got people's skills. Everybody's got very is quite talented and skilled. So all these things have matured into a melting pot just at this moment in time. So Rob, I don't know if we're a little bit late to the party, but it's a good time to be in the digital twinning space, right?
Better late than never, right? Absolutely. How often, if I talked about my background. In between a lot of those, I work for lots of startups, and I do, the first startup I ever worked for, right when I got out of the military, was this company called Real Time Data, and we were literally monitoring vending machines, and they were dumb, and we had radio RF engineers. We building our own data modems because it was primitive cellular back then. But we were just trying to remotely know the inventory, and what do we need to bring to refill a vending machine. But we had to build. We didn't know it at the time. Like, we didn't know what IoT was. We just knew we were communicating over some network to get data about a thing. And we also didn't know when we had to create kind of classifications of different types of vending machines from different manufacturers. When I talk about that digital twin type or model, and so think of it as like the original blueprint for a particular thing, an asset, and all the things about it from one manufacturer. And then there'd be multiple instances of the twin in the real world, right? But you'd use that model to help define everything for you, and then you inherit from it, kind of like object-oriented programming. I'm sure everybody in the audience is a deep programmer right now, like everyone is, of course.
I'm sure they know what that is.
and so they know about having a base class and inheriting from it, and so, which is kind of where my head was with digital twins usually as well anyway. And so that's geeky stuff, but you find it in the real world, you find that to be helpful. When you talk about how they've evolved, I mean, you're right, names come up with a lot of great stuff. There's I used to just say connect, collect, analyze, act, and all that data you're getting. You're hydrating the digital version of the real thing. And then you could be applying analytics of different types to all the different properties of that digital twin. So going back to the simple example with the pickup truck and the tires, you may have I know it's boring not to talk about AI all the time like everybody does, but you might have just simple kind of triggering thresholds. Like, for instance, if the tire gets too low in its inflation and it hits some threshold, you might trigger an action. So simple analytics. So if we think of the dumbest analytics in the world, like if this, then that, right? Branching logic that a child can do. But you know what? Sometimes that's actually all you need. And then more advanced stuff would be AI. And I am emotionally disturbed by the fact that right now, whenever someone says AI, what they really mean is generative AI. Like, the whole planet all of a sudden became experts at AI because of ChatGPT.
Yeah.
But don't forget the other stuff that belongs to the world of AI, like computer vision and different types of machine learning, because that stuff is all very valuable. And so I'll throw something out here that will seem strange. All right. So let's say I have a digital twin of my thing, whatever it is, my truck. And I've got all this data going in, and I'm hydrating the digital twin. In my mind, that digital twin can also be a machine learning model. So, we talk about AI models. Everybody seems to know what that is now because of LLMs, but it's a machine learning model. And so what is it doing? With every few seconds, every minute, every hour, whatever, new telemetry about the current state of the physical twin is arriving and hydrating the digital twin. And so you have the latest state of the thing, and then you have historical state over time, right? And maybe that's all landing in a database, and it's in rows and columns but describe that thing. Well, you can, when you're doing machine learning, there's this notion of you're going to create a model. There's so instead of properties or attributes of a digital twin in machine learning, you might say, I've got features is what it's called, that map to properties, and I have a label. So one of the things people have always tried to do in industrial IoT is they want to do that predictive maintenance, right? They want to find out a machine's going to fail before it fails so they can fix it before it fails, right? Uptime, that kind of thing. And so you can imagine how the digital twin is also your machine learning model. And so all that goes through. And then, like, when you're using machine learning tools, you will map all those properties of the thing to features in a digital twin model. And then there's something called the label, which in this case, it's really simple. Maybe it's running or it's not running. It failed, right? And then you've got all this historical data, and you train that model with all that stuff that's coming in to hydrate your digital twin anyway, right? It's kind of like a 2-for-1. Your digital twin also gets to be your AI model at the same time. And then you run all these algorithms and you predict the future, right? And when something's going to change. You have information. Go ahead.
Yeah, that was actually one of my questions. How is AI shaping the future of digital twins? That was one of my questions. So
Yeah. And I love to just put a stake in the ground and say things that no one believes and then have to prove that it actually works.
What about you, Naeem?
So I'd go with Rob. It's so a digital twin definition. Rob gave a really good example, and examples are the best way, really, rather than you get theoretical definitions and everybody says, "Oh, what does that mean?" Right? So they're important, but the real thing is through examples. And look, you've got a basic digital twin, which simply gives you situational awareness, as Rob says. You've got a farm. Maybe it's a cool farm. Maybe it's a vertical farming. Maybe it's a traditional agricultural farm. I think, Rob, you've dealt with farming before. I think you have.
I have. Yes. Yeah. I
So
love
you've
it.
got that, and the sensors are there. They tell you, okay, how's my farm doing? Yes, it's good enough that what's my crop going to be? What was it? So when Rob talks about historical data, you look at all historical data, and based on when the algorithms learn that the farm produced maximum crop yield with these attributes and parameters over this time, over these seasons, then the algorithms learn that, and then that gets applied to optimize the output of that farm. So those sensors and that environment, as Rob said, whether it's a truck, whether it's a farm, whatever that environment is, when you learn using AI agents and you learn using the algorithms and you apply that on top of the digital twin, it allows you to create behavioral aspects of the real environment in the digital environment. And we all know, if you've got a physical environment. So last week I was talking to a company who want to work with us to look at crowd control and crowd monitoring, and particularly in sort of concentrated environments, whether it's a football game or whether it's a religious festival and things like that. And there are so many cameras around, and you've got to if you can take that and apply machine vision to that, and you can't have, if you've got 6,000 cameras, you can't have a control room with a bunch of people sitting there monitoring those 6,000 cameras. So when you put that through machine vision, and it says, okay, there's some vectors here, there's a large number of people gathering in this area, moving at a certain pace, that could lead to a potential crash. Then that allows automatic opening of gates, and that's the next thing, Rob, right? Yeah. It's automation. So first you predict, and then you automate, and then you automate based on how safety critical it is. You don't want to automate the movement of an aircraft, maybe, but with people in it. But maybe you do want to automate, opening gates to allow relief of pressure of whether it's crowd or movement of goods or people.
Absolutely. No, that makes perfect sense. I mean, automation is kind of the end goal of a lot of this stuff. If you're not taking an action on the insights that you derive, then what was the point of all of this, right? And so, or like on the farm, I'm in an apple orchard, and I have a collection, a block, maybe an acre block of apple trees, and I'm measuring soil moisture and things like that. And then what's the action I take once it's too dry? The action is I connect to an automated irrigation system and turn on the sprinklers, right? Until you're back in the green zone, and why would I care about that in agriculture? Turns out we have labor shortages in agriculture. It turns out kids don't want to work on the farm anymore. What? And they don't want to work in factories either. And so when you find, even though it seems like we got all these extra people who want to do stuff, but we have these labor shortages, and that's where the word automation comes in. It's like, okay, if I can't get enough people to do this job, because there's jobs to be done, right? Then I'm going to have to use my IoT and digital twins and AI to fill that role.
Yeah.
Maybe that's your new employee, right? And so, I don't have enough people in the farm, and so I'm going to automate this whole thing. And then it's it's like a lights out factory, like, something like that.
So just to go back to the real world for people watching, like, why would we use a digital twin? It's efficiency, sustainability, cost savings. Do you have a compelling case study where digital twinning made a significant difference in either of those, efficiency, sustainability, or cost savings?
Sure. It's a boring example, but like certainly when I was at Hitachi, kind of like how GE did when they created GE Digital and Predix, the first customer was Hitachi itself. And so Hitachi is a giant industrial conglomerate, kind of like Siemens or GE, companies like that, right? And so we ultimately built Lumada to use internally initially. And so there's lots of factories and assembly lines. And so we would model with the digital twins industrial robots along an assembly line making something, right? You're doing discrete manufacturing, you're creating something on an assembly line. And so each industrial robot we had a digital twin of each of these industrial robots that's doing its stuff, making things, right? We also have this notion too of sometimes you have a subsystem of a machine that's so complex that maybe it deserves its own digital twin. And so we had this notion of a parent-child relationship between a subsystem and the overall robot. Just like you might have a parent-child relationship between the engine of a car and the overall car. And they map together. And so then you can imagine all my robots working together create a digital twin called an assembly line. And so rather than us just saying assembly line is just a group, we actually made twins out of groups and things to help for the process. Sometimes I'll compare that to like a Russian doll, where you keep pulling it apart and everything. And then you had all the different assembly lines of twins all made together to create a smart factory, for instance. So we actually did that and would bring these systems to life. And so I thought, a lot of people were trying to do that with just straight IoT without really modeling what the things really were. It just makes it a more holistic system. And so we absolutely did that. And things have changed. Back then, we had lots of PhD data scientists helping us with algorithms to apply to that data. And there's also the notion, a lot of people think that somehow IoT and all that stuff has to be in the cloud. That's just not true. Sometimes you need to do that compute really closely because you might need millisecond or nanosecond response times, right, to things happening. And so building a smart factory, making that work and driving value, because what happens, I always tell people, like, when they're trying to find success in IoT, I kind of lump them together. IoT is the plumbing that makes digital twins alive. And then some kind of analytics are applied to the data that it's in the digital twin to drive value, and then you take an action. And so I always pull all those things together and to drive value. And then you get that value that comes out there. I always tell people, follow the money. I'll talk to a plant manager that's making cars at a plant, and they'll tell you, if this industrial robot here on this assembly line fails, then that means the whole assembly line goes down and it stops, and production of the cars I'm making stops. And they might tell me, I won't say the name of the car company in Europe, but they're like, when my assembly line goes down, it's costing me 300,000 euros per hour, then I'm losing money. And that's where, for a lot of people, as soon as they start hearing that they're losing money, that's where they wake up and go, oh, maybe this is important after all.
Yeah.
It's not just helping the world. It's like, it's helping my pocketbook. And so their ability to not have that and to be able to predict and see what's happening, whether you're catching a problem early or whether you're predicting it because you're using machine learning, you can see these problems happening around the corner. So,
yeah, that's what's something that Naeem talks about a lot as well. And sustainability, Naeem, have you any examples, real world case study?
In many ways, digital twins contribute towards sustainability anyway, because they optimize it and refine processes. And the idea is you do the same thing with less effort, or you automate. But the work we're doing in obviously we're doing some amazing work with an incredible university, KAUST, King Abdullah University in Saudi Arabia, and they're restoring about 2 million corals over the next 4 or 5 years, which is a phenomenal task, and we're very fortunate to be part of that. And we're part of a collaborative group building a digital twin that models that first all the IoT devices and all the sensors. So you create a sensor strategy. What is it you're trying to measure? Before that, what problem are you trying to solve? And then you pull all that data back. And the idea is, again, to see what the best way is, to which corals are happy to go with which ones, and which ones flourish in which environments. And so you optimize for sustainability there. Other things we're talking about is we're looking at, looking at seagrass, kelp forests, how to optimize those. So those are all areas we aspire to work into, and we're already talking to some companies within the UK in particular now. So we want to bring some of the lessons we're learning from abroad back home as well, which we're really excited about. And recently we've been talking to sort of social housing company where they've got X thousand homes, and they want to reach their net zero targets earlier or as quickly as possible. So, helping them to embed IoT devices so that, how well efficiently are the boilers, how much mold is there, how much draft is there through the windows. And then you look at that throughout all the housing, and you look, is it worth replacing some of the windows? Is it worth replacing some of the boilers? Is it worth, do some of them need maintenance? So you do all of that, and then you look at the groups of housing, and maybe some of them are old, and it's for them to reach the net zero, it doesn't make for that sense, maybe even for them to hold on to those assets. They sell those and they buy modern housing, which is much more efficient. So with those things, they can feed that information into the twin, and they can project forward. It's the what now is what is the environment that we're monitoring now, the current situation and awareness. If we did this, and this, what would it do to our CO2 emissions? And projecting forward, would we meet our net zero 10 years in advance? Or if we didn't do that, would we end up missing our net zero? So all that, exciting stuff.
That's good stuff.
Happening with those digital twins, yeah.
It is.
I think it's just great that you can use digital twins and sensors for a bigger purpose, right? It's not just to make a factory more efficient. Maybe the real purpose for all this technology was to help save the planet.
Maybe
it's always fun to have a bigger purpose, right?
Absolutely. Yeah. And I think that like you must have challenges though, because like what are the biggest challenges companies face when implementing digital twins? Have you come across that, Rob? Challenges?
Well, most people don't know what they don't know. They may not know they need some kind of runtime platform for the digital twins to live in, because I hear lots of people saying, oh yeah, we build digital twins all the time and we did this. I'm like, well, tell me what you did. Oh, we got some documents and some drawings here and and everything like that. And we made a digital twin, and they say it really fast and loose. And I'm like, really? Did you? Because it's software. A digital twin is software, but it's not just in an abstract. It's got to live in some kind of runtime environment. Yeah, and the only reason I say that is because I built a few of those things where you have an environment where you're composable digital twins. I'm gonna compose based on I'm sorry I keep overusing that stupid car example. Think of the owner's manual that's in the glove compartment of your car that you just bought. Think of that as the text real world version of the data about the digital twin. But anyway, it needs to live somewhere. It's running in a platform, data streaming into it. It's alive. It's in memory, maybe. It could just be in a database. Things are triggering, stuff like that. And so it's not just some pictures and documents. That might be collateral that adds to it, but absolutely, there's more. Oh, looks like we got a question.
We have a question from a gentleman called Mark. Digital twin of ocean DTO initiated by the EU. What do you think of these massive scale digital twins? Is it real?
I don't know. He's the ocean expert with.
So yeah, it's look, I mean, just going back before I answer that, just going back to what Rob was saying and Sam, to your earlier point, there's, I think it's our responsibility in a way to sort of create awareness of digital twins as well, because as Rob says, you don't, a lot of people don't know the benefits that you can have. So coming on here and chatting about these kind of things and discussing them and discussing the benefits and solving real world problems, I think that's a pro for us. The big scale projects, I would say, so I always like starting things small. So you solve a small problem in a regional area, you solve the next problem. So going back to that EU thing, if you want to solve something which is quite significant, then obviously you have to pan out on your level of abstraction so that you're looking at bigger measurements. But for me, it's creating correlations between different data sets, whether they be it within a small scale within a particular environment, or whether they be it in a bigger environment. Some things you could argue, particularly where you talk about having climate change impacts, you do need the bigger picture. So I can see almost sort of at a macro level digital twins, and this is probably touching on the future of digital twins, where you create interoperability. They can talk to each other. So you've got the smaller digital twins informing each other and almost sort of creating a network of twins. So those feeding into a bigger abstraction layer and creating. So for example, if we want to not model, so the example we're looking at in the coral reef restoration is within 100 hectares, but you could argue, well, let's look at the Red Sea as a whole, and then that macro level movement of the environment will impact the micro level. So they are connected, and it's highly ambitious. But I'm just always a little bit skeptical of very large projects because they take so long to come off the ground.
Yeah, you know what? That's because you're right. That's a broad, big thing. The whole ocean. If you would indulge me, I'd love to give a simple example and a recipe that people can, So like, there's these 17 sustainable development goals that the United Nations created a long time ago with targets to hit all these things by 2030. Sadly, we're probably going to miss almost all of those targets, unfortunately, because just people aren't taking action like I thought or hoped that they might around sustainability. But what's great about those is it helps categorize things for you, because ultimately, once you know the technology and you know how to build this stuff in your sleep, what's really important are the use cases. How do I actually tackle these different problems? Like, am I tackling coral reef acidification because of climate change and too much CO2 getting absorbed into the ocean, and it's acidifying, and then the habitat for fish declines, right? That's a problem. So that's life below water. There's life on land. There's climate change. So I'm going to run through a quick recipe of a simple thing that anybody could do. So sustainable goal, SDG 15, is about life on land. And there's all kinds of use cases of what do I want to do to help make the world a better place. And so one of them might be deforestation, because we know if we keep cutting down trees, and trees are a great way as a great CO2 sink, right? To help get all that stuff out of the air. But deforestation could be happening due to illegal logging, right? So if people are cutting down trees where they're not supposed to be. And so I'll give you a recipe for, well, what would I do about that? How do I detect illegal logging? And so you kind of need a blueprint. If I want to empower people to go out and change the world, they need to know what to do. And so I might say, okay, you're going to need a bunch of sensors. I need acoustic sensors to listen for chainsaws. I might need cameras for computer vision to detect unexpected people or vehicles in an area where they don't belong. I might do motion detectors as well. What's my device? I'm going to use some kind of microcontroller. How am I going to power that microcontroller? I might use lithium ion polymer little batteries. I might use solar. Okay, how do I get that data somewhere? I need a network. Well, if there's no connectivity in that region right there, if there was cellular, I might use cellular. I might use LoRaWAN, that low bit rate technology that can go like 10 or 15 kilometers. where maybe I can reach an internet access point to get somewhere else. If there's nothing, I might have to use satellite. And then the digital twin modeling. What am I modeling? I'm modeling a collection of trees in a protected forest area is what I'm modeling. I might model logging roads. Where am I going to store data and process it? You hear about edge computing and cloud computing. I might initially do some local edge computing, capturing that data locally and maybe filtering stuff. And then I might send relay data up to a cloud to analyze larger areas. What kind of analytics am I going to do? I might just compare sensor values to thresholds or KPI ranges. If I don't hear anything, then I'm in the green zone, right? I'm in a green KPI. If I hear, I might have a yellow warning, like, oh, I think there's something approaching. And then a red alert might be, yes, I'm hearing a chainsaw and someone's chopping down a tree, right? And then, and then there's people involved. People have to deploy the solution. They have to maintain the solution. You have subject matter experts, SMEs. They're the ones who are going to define kind of your KPIs and analytics that you care about. And then the people who are going to take action in this forest, maybe it's forest rangers or police or authorities or whatever. So that's just kind of a simple little blueprint. And so you can imagine taking a little blueprint like this and applying it to thousands of scenarios across hunger or climate or life below water or, things like that, sustainable cities. Anyway, I'm just rambling here, but I feel like it's important if we're going to make a difference on a large scale, we have to give people, all right, page 25, here's how I do it. This sensor, this network, this KPI, this whatever, boom. With the technology that I need to make it work as well, right?
Yeah, but that's all about awareness. And that's why we're doing this. And that's why DigiCore is so passionate about spreading the message about digital twinning. And that's one of the reasons we're doing this today and finding great people like yourself, Rob, that you just are so enthusiastic about the topic. You can feel it through the screen, can't you? You're so passionate about this. So, but we are going over time. So I just wanted to, if anyone has a question, please put it in the comments and we will ask questions.
I had a question for Rob as well, if that's
Yes.
all right, Rob. I just, with all the latest AI and the chat of generative AI and, with the hype and where AI is at the moment, you Rob, talk a lot to, you advise the UK government, the US government, you go to the Pentagon, you advise the military in the US. I'm an optimist about AI. What do you get from them? Are they, I know it depends on people to people, but what's the sense? Are they worried about something? Do you get that feeling or not?
They're extremely worried. Yeah. About 3 times a year. Yeah. So I lecture senior military officers in the US military about 3 times a year, it could be at Pearl Harbor or Pentagon or whatever. And yeah, without giving away any secret stuff, especially when this whole generative AI came about, there was a lot of concern by all of these admirals and generals. We've heard terms like deep fakes for a long time, but now what used to take having an expensive multi-million-dollar movie studio, now you can do on your laptop, right? And so they are very concerned that we can create videos, create images of people. We can create voices that sound like your daughter calling you and saying, Dad, I've been kidnapped, help me, or whatever. I need you to send money. And so they're extremely worried. They've already seen fake explosions at the Pentagon that weren't real. But people didn't know and they thought it was real. And so, there is tremendous concern around this kind of technology to create and spread disinformation that could cause chaos and cause people to take actions they don't need or wrong actions or things like that aren't real. And so, a tremendous amount of concern around generative AI. It's kind of weird, kind of scary.
And looking ahead, before we wrap up, how do you see digital twins integrating with other like IoT, other technologies, metaverse, stuff like that? I think you kind of touched on that earlier.
Metaverse.
Oh.
Yes. Yeah. Why do you get Zuckerberg on the phone and talk about his metaverse? I do remember when Facebook talked about, oh, wow, we spent all this money building a metaverse that hadn't really kind of happened too much. And I remember going to Mobile World Congress right after those announcements, and every company there had the word metaverse on their stand, on their booth. All of a sudden, it's like, oh, we got to pivot and talk about this cool new thing.
Yeah.
what's interesting though is digital twins are a foundational component of a metaverse. And so if we are living in a world with our little headsets on, right? From different vendors and creating this digital world, what are those things, the avatars in that metaverse, and so they're defined by a digital twin. They're brought to life with analytics and data and things like that. But yeah, you have to start with the structure. It's like I tell people all the time, remember, a lot of people think digital twin is a 3D model, and I go, it could be. That's actually a view of a digital twin, but at its heart, a digital twin is just a data structure that defines something, and then you expound upon that however you want. And so in the metaverse, we're creating structures of the three of us, sitting around a campfire outside. Yeah, and so we'll get there, but who knows?
Could happen.
It could happen.
Especially if we're going to collaborate more. I mean, definitely, Naeem, I'll let you wrap up there. What do you think looking ahead? How do you see?
Yeah, I mean, Rob's right. Some of it is more hype than reality, but certainly look, whenever something is in this hype cycle like digital twin, everybody wants to mention the word digital twin. So if you think back, first it was big data, that was a big thing, that was the thing, and then people forgot about it. And then IoT, that was the big thing, right? And then people kind of said, okay, and then that becomes the norm. It just becomes part of the. So today is digital twins, but soon they'll become the norm, and it will just be a given that they're integral part of a system that's deployed, and the hype won't be there. So that's one thing, and the other thing is probably for future, of course, with that AI and IoT and advancement in cloud computing, they'll just get more and more realistic in terms of behavior, in terms of accuracy of the real thing, to the point where they can make great predictions, and they can be very efficient and cost effective in solving physical problems. And I think 6G will, whenever it lands, maybe that will be a big thing, because it's going to integrate autonomous cars and allow AI as Rob called it, at the edge, and maybe cars can talk to each other to avoid pedestrians, rather than going back to a central place where they need to talk to as well. So I think it's collaborative AI or something like that it's called. But yeah, so there's a lot of exciting stuff coming our way. But the key thing is they'll become more and more accurate.
Well, definitely, anyone who's watching, Rob, have you anything coming up you'd like us to mention? I mean, for people watching, definitely connect with Rob, follow his journey, follow him on Twitter. He has a YouTube as well. Connect with him here on LinkedIn. Naeem, same with Naeem. If you want to follow the journey and see what they're up to, definitely check out Digicore. Definitely, Digicore is also here on LinkedIn and Twitter. Rob, is there anything you'd like us to mention before we wrap up? Anything you're up to? Anything coming up?
Upcoming events? Yeah, I'm flying to Texas, and I'm going to be at Edge AI conference in Austin, Texas next week. I'm going to be there on Tuesday, and so being able to take AI down to smaller things, even a microcontroller. They used to be called the Tiny ML Foundation, and now it's Edge AI Foundation, because that sounds sexier, I guess. And so that's what they're doing. And so I'm doing that. But then I'm jumping over to Houston, and I'm actually at a ESG conference that I'm on the board of, and where we actually were talking about sustainability in the oil and gas industry, which is a very tall order, you can imagine. And so I will be there talking about how we can apply some of the things we're discussing right now to help reduce emissions and things in the oil and gas industry. So that's always interesting. If we can get them to change, then everything else should be easy, right? But it's tough. It's tough, So measuring methane and CO2 emissions and things like that, continuous monitoring, use this IoT and digital twins for something good to help the world, for sure. So yeah, that's what I'm up to lately.
Well, that's a lovely way to wrap up. And I know, Naeem, you've got some trips to Saudi coming up, and anything you want to mention before we?
No, just I would like to say that, and by the way, the Saudis are doing some amazing work. If you go and check out, what they're doing at NEOM and the transformation that they've got, and their 2030 vision, it's mind blowing, and they're not just talking about it; they're doing it.
Yeah.
And if you can be part of that, be part of it, because a lot of it is about it's all geared towards sustainability. So and we all
Definitely, yeah, and definitely. I mean, definitely, what you're doing is amazing. What you're both doing is amazing. So I look forward to following your journeys. And Matthew, thank you for joining us. Mark, we actually have 138 people watching. So thank you, everybody, for watching and listening. And we really appreciate your support. Maybe perhaps you could share this, please, for us afterwards. And do comment and connect with Naeem and Rob. So thank you, guys. Thank you, gentlemen.
Thanks, Sam. Thanks for hosting.
Thanks for having me. This is great.
See you soon.
You're welcome. Thanks for coming. And we'll see you for the next one, folks. We will again.
Bye, everybody.